Alright class, so I'm back with this data file that we just converted from Excel, and it pretty much gives you about 5 variables, 3 of which are categorical or qualitative, and the other 2 are numerical or quantitative. If you look at salary, you may remember that salary would be an ratio data set because it has a natural 0. And so is count. You don't count negative. So both salary and count are ratio data. And gender, region, and whether or not you have a retirement account are all nominal data. So one of the questions you could ask is, what is the average salary of the respondents to this particular survey? So in order to do that, remember you have to look at salary. That's my variable. We use an analyze. You go to descriptive statistics. There's a number of ways you can find average salary. One way is the frequency, right? And you bring salary over and you click on statistics here, and you can choose what you want: mean, medians, modes, sums, or whatever. And since we're looking at all of them, let's just click mean, median, and mode. Okay? These are the dispersions or variations: min, max, range, standard deviation, variance. I'm going to leave those alone for now. Okay. Click continue. I don't need the frequency table, so I can take that off. Click OK. And what it will give you is the answer to the number. Okay. The mean is $106,262.50. And the median is $60,750 and no cents. And it says multiple modes exist, and the smallest is 0. Okay? So what does this mean? This means you found your mean, your median, and your mode of these 20 data points pretty quickly. Okay? So when you look at a data set like this where mean is so much larger than the median, this has the tendency of looking like a positively skewed data because we have high outliers which tend to pull the mean towards the tail. And surely when you look at this, there's a guy with $945,000 here, which makes the average $106,000. Everyone else is at least between 140, 150 or less. And you can see that just that one person here actually pulled this thing up about $40,000, $50,000. And we can even show that if we ignore him. Okay? So let's go and actually filter him out and recalculate the frequency, and you can see what happens. So data, select cases. Okay? And in this case, I want to select all the cases where salary is not $945,000. And you can type 945000 and click continue. I'm going to leave them in my data set, so I'm not going to do anything here. Just click OK, and you'll notice there's that line that shows up next to his number. If I redo the frequency to calculate my mean, medians, and modes, what you see is that the mean is now 62,118, and my median is 55,000. Okay? So just that one number pulled the mean all the way up towards 100 and what number was that? 106. It's about $40,000 more just by ignoring him. This is the effect of an outlier on the mean. So I'm going to put him back in because I want to show you the second way to get your frequency. Okay? Back to data, select cases. Let's use everyone. But this time, rather than do frequency, I'm going to do descriptives. So I can do analyze, descriptive statistics, descriptives. Here, I want salary again. There are other options: mean, median, and mode, mean, sum, standard deviation, min, max. I don't care about those right now. Okay, I just want mean. So if you want to get median and mode, you need to do the frequency. But this will give you mean and standard deviation, variance, range, etc. Click continue, click OK, and remember that 106.26250? We see it again here. Okay? So when you're calculating mean, median, and mode, you can use frequencies or you can use descriptives. All right. There's another one here too called explore. If you want to do explore, you put salary and dependent lists, and the statistics, they'll give you all the descriptors as well. And it also will tell you if there are any outliers. Now we haven't defined what an outlier is, but there is an actual way to identify values that may have a large effect on what's going on. And those are called outliers. Click continue and just click. I don't want any plots at this point, so I just want statistics. I'm just going to change that to statistics. And you notice the word plots gets grayed out here, and click OK. Okay. And what you see for the explore, it gives you the mean, the median, the variance, standard deviation. It gives you everything. Everything except for the mode, of course. So again, you see that 6750. You saw that previously above. So if you're just trying to find descriptive statistics, you can literally use the frequency, descriptive, or explore, and it will give you your answer. So on a more fundamental issue though, okay, more fundamental issue is that sometimes, and I'm actually going to get rid of this filter because we don't need it anymore. Sometimes you have data and it's created in such a way that it really summarizes the data. So for example, on this first line, this could represent people who are male from the North region who have retirement accounts, and all of them have a salary of $36,000. So the question is, how many people does that look like? And you see here under the count variable, we're assuming there's 69 people that have that count variable. Okay? So we have 69 males from the North with retirement accounts with an average salary of $36,000. We have 44 here for male, 22, 11, 65 going on down the line. So when we look at salary and we look at the average salary, it's no longer just the average of these 20 numbers, which it would be if each line represented a row, but if each line represented a value or record. But each line represents multiple records. So we need to have a way to weight each of these values so that rather than write down 36,069 times, I can let SPSS know that when you see this type of data, count it 69 times. This is called a weighted sum that you'll see in chapter 4 of your textbook, where you have two groups and you multiply the subgroup value together, add them together, and then divide it by the total. So we can do this as well in Excel. Oh, I'm sorry, not Excel, in SPSS. You're really going to have a hard time doing it in Excel. But in SPSS, we can go to Data. In this case, we want to weight the data. What weight data says is, each time you see this row, count it this many times. And the number of times you want to count it is defined as this variable count. So you click OK. All right. And so now every time I run a value, it will tell me how many times to count it. So if I do let's do explore again. All right. And click OK. Now, notice what happened before. Before, it was reading it off of 20 lines, where each line was its own data set. Now, it's reading 1,051 lines. This you can see by adding the count variable. And I'll show you that too. If I just do descriptive statistics, descriptives on count, but in this case I just want to find the sum of count, you'll see it adds up to 1051. There it is. Okay. So when I have my weight on, you now see that the mean is no longer 60,000 or 106,000, but it's 93,210. So the reason why it increased is because I have the larger weights near the higher salaries. Okay? So you want to do a weighted sum? Go to Data, Weight Cases, choose your weight as the weight cases by, and run your analysis as normal. And that, my friends, is the central tendencies that are most common in SPSS and SAS and Excel and pretty much any other analysis that we'll have to do in the social sciences. Okay? When I see you again, we're going to talk about the variations. Talk to you soon.